So our next construction here, much like our last one, is really best served by being looked at through the lens of a diagram, an example, a picture that shows what we're talking about with parallel lines and transversal lines. So let's say that we have a collection of three lines like so here, where the ones at the top and bottom are called parallel because, as we can see here, they are crossing along with the same slope. They're never going to intersect, they're never going to touch, they're always going to stay the exact same distance apart from one another, where that idea of slope is an important one that we're not going to dig in too much for right now, that we just have this construction of those two lines crossing like so, that are never going to get any closer to each other, and then we have the transversal that cuts along the pair of them. So that's the diagonal that goes through them there, that is our transversal lines, where with transversal lines and parallels, we have some very important relationships that occur in terms of those collection of 8 angles, where we have constructions like alternate interior angles, which are angles that do not have a common vertex, are on the inside, as it were, of the parallel lines, and on opposite sides of the transversal, like 3 with 6 and 4 with 5, where we have that alternate interior angles have the same measure. 3 is equal to 6 in measure, 4 is equal to 5 in measure. Then we have alternate exterior angles, which are similarly defined, except now they're on the outside of those parallels. So we're talking about things like 1 with 8, along with 2 and 7, and these also have the same measure. The measure of 1 is equal to the measure of 8, the measure of 2 is equal to the measure of 7, and then finally we have corresponding angles, where these are the ones that are 1 interior, 1 exterior of the parallels along the same side of the transversal. So 1 with 5, 3 with 7, 2 with 6, and 4 with 8, where corresponding angles also have the same measure. And in terms of this diagram, hopefully you can tell, just looking at it, thinking about how these things would come together, at the very least based on scale, it should make sense, although you shouldn't always assume things are drawn to scale. But essentially what we're doing here is just taking the idea of vertical angles and extending it to further relationships. It's really all just things with supplementary angles and complementary angles again. But to help understand this, really what we should do is take an example to define some of these angles given some selection of them. So for the parallel and transversal lines given below, determine the missing angles given that the measure of angle 8 is 35 degrees. And there are a whole bunch of different ways that we can go about getting all of these things, whether we want to jump straight to the relationships we saw in terms of alternate interior, alternate exterior, corresponding angles, what have you. It's really a free-for-all here about what you might want to define first. Me personally, I'm going to go along with the things that I have the most comfort and confidence in dealing with, which is the vertical lines, the supplementary angles, and then going from there to extend more in terms of the alternate parts. So the first thing we can look at here is that our angle 8 is a vertical angle in relationship to the angle 1. So given that relationship, we can have here that the measure of angle 1 is going to have to be 35 degrees. Then from there, we can talk about the measures of angles 6 and 7 in terms of the measures of angles 1 and 8. That both of those, thanks to being vertical in that same sort of setting, go with them. They are supplementary. We will have that the measure of 6 is equal to the measure of angle 7, and in both cases is going to be 180 minus 35. I'm not going to write that out because hopefully you can get that that will be 145 degrees. And then from there we're kind of stuck dealing with things in terms of our alternate interiors, exteriors, and whatever else you may want, where in this case I am going to recognize the corresponding angles 1 and 2, and see here that the measure of angle 2 is also going to be 35 degrees because it is a corresponding angle with 1. Similarly, the angle 5 is a corresponding angle with, well, 8, back where we started. So the measure of angle 5 is also a going to be 35 degrees. Maybe I should just write these in even though I'm trying to align them so that is clear. But we've got those two parts there. And hey, guess what? Those were also vertical angles with each other. So they should have been 35 for that reason too. There's a lot of redundancy, a lot of different ways you can go about this. And for fundamentally the same reason, hey, guess what? The measure of angle 3 is also going to be 145 degrees because you can either see that measure of angle 3 as being a corresponding angle with 6 or an alternate interior angle with 7, and then the measure for angle 4 is going to be 145 for, so many reasons at this point. Either you could say the measure of angle 4 is equal to 145 because it is supplementary with each of 2 and 5 separately. It is also a vertical angle with relationship to 3. It is also a corresponding angle with relationship to 7. It is also an alternate exterior angle with relation to 6, and I think that covers all of them, but it probably doesn't because a lot of these, as I said, refer to the same sorts of relationships, just pushed around. It's all about supplementary angles when it comes to these things. If you understand that type of idea and then can see the relationship pictographically, it should make some sense. But that's about all we have here for our first section here for section 10.1. Next, we're going to move into section 10.2, where we are going to be talking about our most basic shape, the triangle. See you in there.